Welcome to DEFN, episode number 58-ish, I think. We took a bit of a break, willingly, and we thought there is enough of DEFN already, but then we realized there is not enough of DEFN already, so we're going to get back to recording a nice episode for everybody who is staying safe and healthy and staying at home in this strange times. And we decided we're going to get an awesome guest, literally. So we looked for how do we spell awesome in Norwegian. It turned out to be ASSUM, I guess. So welcome to DEFN, Erik Assum.
Thank you. It is a real honor and privilege to be here. I'm sad for the program though, because you've had like important and brilliant people before, and I guess now it's just going downhill since you have to reach out to me.
No, that's. I mean, there were a couple of episodes where there were no guests, so that was our low point already. And that was like a completely, levels and levels of, below.
We've set the bar incredibly low for this show.
Okay, good.
So, I mean, in fairness, you're just about clearing it, Erik, but, we'll see.
Yeah.
So, maybe I think it's good to have a quick introduction about what you're doing right now, Erik.
Yeah, so I'm a programmer at a Norwegian company called Ardoc, and I've been there for 2.5 years, and been programming since 95, I think, professionally. That's 1995, like for the young people.
I mean, I was thinking 1895 or 1795. I mean, because I'm used to race time period,
Yeah. So, but the thing is that I think I look upon myself as a fairly normal programmer, like nothing special, and that's why I'm a little bit confused why I'm here.
I mean, why you're here, as in why you're in Norway, or
no, why I'm on the DEFN podcast is like you've had Zach Tellman, you've had Stuart Holloway, and like these people that are super brilliant, and then you have me working as a programmer in Norway and would probably rather be rock climbing or something,
Yeah, but it's okay though, because I think the point about our program is that you don't come on here and code, you come on here and talk, and we've both talked to you plenty, Erik, and we know you can do that. So,
yeah.
I mean, you already pointed out that we only invite brilliant guests onto the podcast, so
previously before the hiatus.
No, that's not true. So I think maybe we can start with something that's more recent. And you gave a really nice talk at Clojure, Erik. It was really, um, how do you say that? You're putting your knowledge out there, and maybe it's instead of me paraphrasing and then bullshitting my way through that one, it would be nice if you can talk about what you talked about at Clojure.
Yeah. So I have a colleague who said that he wants to find this big problem that he wants to work on and solve. And I think that the thing that I'm really interested in is writing, like, what is good code? What is good code? How do you write good code? And that's one of the reasons I wanted to work professionally with Clojure, is that um, it seemed like a fun tool for writing your own little toy programs, but does it scale when you were several developers working with it over time? And the talk that I gave at Clojure D was sort of some of the observations that I've done, that when you work in a dynamic language where you don't have to name that many things, what are the pitfalls you can fall into? And what are the things that you might do if you program in Java where you have to name everything, that you should maybe bring over to Clojure, even though you don't have to name everything?
Yeah, and because I mean, obviously, it's almost 25 years of coding.
Yeah.
So what was the journey? Because obviously the lessons that you're putting into Clojure programming are from different um, building different sorts of systems over the years, right?
Yeah, so I started out working in awk.
Oh yeah.
Okay.
Yeah, my education is in Simula, which is sort of the first object oriented programming. If you don't listen to Alan Kay.
Yeah.
Um, and then I got a summer job doing some stuff in awk, which was basically just text transformation. And
Mhm.
from there, it was easy to transform into web development because at the time it was done in Perl.
Yeah.
Mm, mm.
And in the early days of web, there was a lot of sort of not so interesting stuff to do. So I amused myself with trying to write more obfuscated Perl code, which is, not so hard, but you can write it even more ugly or dense.
Yeah.
And I found that one of the one of the things that I really liked about Perl was you could explore the language. Um, it's like many different ways to do some things, which when I came to Java, it felt like boring. It's just one way to do things, and you have to write a lot of stuff to get that stuff done. And I remember from starting out in Java, it was like, why do I need these classes, these objects? I have maps and lists. That's what
Yeah.
you use in Perl,
In
right?
Perl. Yeah.
And why do you have to tell the compiler that the thing is a string, but when the compiler knows it's a string? It's just a lot of stuff that I found really hard with Java.
Mm.
Yeah, I think one of the things about things like awk and Perl as well is that the feedback loop is incredibly tight, isn't it? Just like any kind of shell interpreted programming. You write a script and
It was built to get stuff done, whereas I felt Java was not.
Yeah.
It's like eventually in Java you could get stuff done, but I mean I can still not read the contents of a file into a variable in Java.
I think that's a funny characteristic observation, though, because I think like C, for example, is quite. It's not as verbose as Java, but the feedback loop isn't as quick. Especially when you get into like C, C++, the compile, linting. Kind of the compile and then the linking, and then the linting, and then you run your program. And I think there are plenty of languages that get things done that don't have immediate feedback loops. Um, but it is painful though. But
Yeah,
I think Java is designed to get things done, but it's designed to get things done in what they consider to be a safe way. I
yeah,
think that's
and
that's the sort of value proposition, if you like, of Java, is that what we will give you is an environment that is safe to run on different platforms.
yeah, but I think it's Java's value proposition is more towards the businesses and the enterprises than it is to the programmer,
Mm.
right? It's not fun to program in Java, but if you have one Java programmer, you can just exchange it for another one. It's safe.
It became like that, right? Maybe initially Java was fun, probably with the maybe 1.2, 1.1, or maybe
Yeah, it felt
1.5
pretty fun
level.
at the beginning for me,
Yeah,
actually. I've
exactly.
got to say, when I
And then
when
later,
I was yeah.
I think with the Java EE stuff came in, and then I think the whole fancy stuff started, and it's really funky that we have Java EE and then J2EE, and then the book. What was the book about? Uh, effective? No, not effective
The
Java.
concurrency.
No, the other book by the guy who that kickstarted the Ruby on Rails sort of movement. So they had this.
Heinemeier?
No, I mean he made the Ruby on Rails, but there was a book that started Spring as well to lightweight Pico containers and all that stuff. And then
Okay.
we started going in that direction, and then Spring became like fucking bloated shit again.
Yeah. But I think in the beginning, though, as Ray says, Java was kind of cool. You had these applet things, right? You could
Yeah, yeah,
create like animations and stuff in the browser,
Sure,
which
sure.
you couldn't do with Perl, right?
Mm.
yeah,
Well, also, I think the fact that you could run Java, like I was used to running to C and C++, the fact that you could write Java without doing memory management was quite an advantage, you know?
Mm.
Yeah, but then there I came from Simula, which was
Sure.
garbage collected, and it
Right.
was
Yeah.
object oriented. So basically, when I saw Java, it was like, yeah, it's Simula in a different language, and it's got this virtual machine. And I think Jamie Zawinski wrote a really nice blog post on that. That what you brand as Java was like three different things. It was the virtual machine,
Yes. Yes.
which we're using in Clojure. Then there's the standard library, and then there's a language.
Language,
Yes.
yeah.
Yes.
And I think that the virtual machine and the standard library was a good thing.
Yeah, I think that's what we are exploiting, quote unquote, exploiting in Clojure and other languages as well, right? The JVM as a technology is really, really mature and useful, and so that's, I think that's one of the.
But also, aren't you like you're glossing over the fact that a lot of the big projects and the big frameworks are written in Java, and without those big frameworks or those big libraries, it's actually quite difficult to do a lot of the work we want to do. Because we
Yep.
can't always just do that in Clojure or write it from scratch.
Yeah, I don't remember who that was, but there was a recent podcast, I think. Someone talked about how Java sort of delivered on this promise of writing, or no, it was Rich Hickey, of course. We had a Rich Hickey lunch talk week.
Oh,
And in one of his talks, he says that C++ couldn't sort of deliver on this reusable code because of memory management. So nobody could agree on who was to clear up the memory, and Java delivered on that, and that's how we have this huge ecosystem of useful
Mm,
libraries and frameworks.
mm, mm.
yeah, I think that makes sense. But coming from Perl, I mean, Perl, obviously, as you said, there is more than one way to do it, the Tim Toady or whatever. And I remember writing some Perl web applications. Um, and then I switched to Java. So how was the transition for you? Was it too far in the past, or
What from
from Perl to Java?
I found it really painful. It felt like you could not get shit done. Um, and I didn't understand why we needed all these classes.
Yeah,
Mm.
And regexes were not a part of Java at that point, and Perl was all regexes.
Yeah, of
So
course.
yeah, that was painful. And also the whole like you when you did web programming with Perl, it was CGI, right? It
yeah,
was
yeah, yeah,
super simple, and then suddenly you have these applications or servlet engines, and you have servlets, and now why would you at that point you had template libraries for Perl, right?
yeah, yeah, yeah.
And
Of course.
then someone comes along and you don't even have JSP yet. You're writing servlets, so you're sitting there with a Java class and you're string concatenating HTML. Now, how do you who the one that managed to sell that is it's incredible.
Yeah, that's strange times. Hmm. Anyway, I mean, luckily, I think eventually JSP showed up. I mean,
Yeah,
not a better one, but slightly more useful, I would say.
yeah, because then you had JSPs, which were like that's like PHP, right?
Yeah,
Because you have this it's a class that's inside out,
yeah, yeah,
and you had a bunch of bad Java code intermingled with HTML code, which was also horrendous. But then taglibs came along and
yeah,
things became sort of usable, I think.
yeah, yeah.
Yeah, I think you had a lot of templates like velocity and stuff like
Free
that,
marker.
which
Yeah,
came a lot nicer. Yeah.
Yeah.
yeah,
But at that point, we were sort of at the company that I was at there. We had Java things that were generating lists, and then you had JSPs which generated XML, and then we had XSL on top of that, which
Oh
transformed the
God. Yeah.
XML into HTML, so that we had reusability all over the place, right?
beautiful.
Yeah. Yeah. Oh man, I've forgotten him. I mean, I'd kind of what. Yeah, I'd kind of forgotten about the whole XML XSL world. Yeah.
Yeah,
Jesus.
which in a way is kind of cool because XSL or XSLT is functional programming in a way,
Yeah,
but
yeah,
it's
Yeah.
just done
yeah,
in XML, so it's really painful.
Yeah. Exactly. Yeah. It's like chocolate wrapped in shit, you know?
Eh?
It's like chocolate wrapped in shit.
Yes.
Nobody wants to eat it.
I'm sure there are plenty of businesses running on XLT transformations. I know some of them, so that was rough.
Well, I mean, to be honest, it's like a lot of this shit. It never goes away. You know, we're using XML still and XSLT for some security protocols like SAML. Still use this shit, and like there are all these weird and wonderful things like ASN1 that still get used in certificate creations. So you know, none of this shit really ever dies. You know.
No, but then I think the problem with XML was that we were using it all over the place, and it was. I think it's a nice format that you can build interfaces on top of, right? Because it's declared, so you know exactly
Sure.
what goes where. So,
Yeah.
but the problem was that we were hand coding this shit and hand reading it.
Yeah. And also for every possible type, it's just XML, and then one more schema, and then let's put everywhere. You know, it's a data interchange format, it's a data storage format, and all the nuisance. And
yeah, I mean, to be honest, as a interchange format, I thought XML was pretty decent. To be honest.
Yep. I mean, now we're stuck with JSON and YAML.
Yeah.
I actually preferred XML over JSON and YAML. To be totally honest, I mean, you know, I don't want to write configuration files in XML.
Yeah, exactly.
I think YAML is better for that. I don't want to write configuration files in JSON.
No,
but I think YAML is good for configuration files.
I so totally disagree.
Okay,
actually,
go for it. That's
the thing is that
now you know why we invited you.
Yeah.
To put us in our place, you know.
You have to we have to define configuration. That's the first thing we have to do, right? And when I say that I hate YAML, it's in terms of configuring like Amazon stuff, AWS, configuring servers and all that stuff, where I think that this declarative approach is failed because you want to be able to do this programmatically. You want to be able to store some state. You want to you want to do this in Clojure. You want to program your thing. It's like a program.
No, sorry, we're talking at cross purposes. What I mean is, if I have to hand code something, I would hand code YAML rather than hand code these other things. But I completely agree with you that infrastructure should be code.
Yeah, and not YAML.
Yes, absolutely. Yeah. But it might bottom out into some serialized format that could be YAML or XML or JSON. Or don't give a shit really.
Yeah.
But you know, I don't want to program complicated things like that in it. Yeah, for sure.
It's one of the reasons I'm staying out of ops is that the tooling there is so horrendous.
Oh yeah, it's a fucking mess.
Yeah.
I mean, especially if you go to cloud, then it's YAML based shit, as you know, probably cloud formation and everything, and they have JSON based shit as well. And then you go into Kubernetes, that's another weird crap out there. And then you have and then you have all the Terraform stuff, and then there is some weird crap there. But I think there are a couple of
well, I've got to say, I mean, I think to your point though, Vijay, I think Terraform and HashiCorp as a company are actually making ops tolerable, at least.
Yeah.
I would say that they seem to be listening to developers and understanding what the pain points are. So I've been quite impressed by the HashiCorp tools, to be honest, and we use them for various configuration things at work, and I think they're pretty good. Yeah. They also take a kind of semi-immutable approach as well. It kind of like, if you think about like what kind of reacted to the DOM, Terraform sort of does to your infrastructure. Now, you don't always want that to happen to your infrastructure, and that's a pain in the ass when you want to do something else. But this notion of having a declarative model that you say, I want my infrastructure to look like this, and it essentially does a diff and makes it happen. It's quite nice.
It applies the changes and it's keeping the state somewhere remote. And
but the problem for me is sort of what what the language you're coding in looks like. It's not at all elegant. It looks like, oh, we tried to do this declarative thing, and then oh shit, we needed for loops.
Oh yeah, absolutely.
And then
yeah. As soon as things get Turing complete, you've got problems. Yeah.
Yeah.
But actually, by the way, on that point, I think myself and VJ were at a conference recently, FOSDEM. We were looking at this thing called Quix or Geeks,
Geeks.
which is
It's
QUIX. Is it?
No, it's GUI.
GUIX.
Yeah, Geeks.
Geeks, which is a kind of scheme version of Nix. And this kind of concept of immutable infrastructure is gaining ground. That could be something that could be interesting for you, Erik, because then it really is kind of proper FP. You can think about your entire operating system as sort of disposable, one-shot things that you really do just that you create once and then throw away. It's problematic for stateful things like databases, but for many things it's quite nice.
And it's Lisp, so it's much nicer.
Yeah.
Yes.
So how did you get into Clojure then, Erik?
Well, that's a couple of years ago in 2013, I guess. I was working on a Java Spring project and sort of getting interested into functional programming. And I bought a couple of books on Scala and a couple of books on Clojure.
Yeah.
And at the time, I thought Scala was the thing to do. But then I saw this talk by Bodil Stokke, a fellow Norwegian. She's living in London now.
Yeah.
And she basically, during this talk, coded up a full CRUD application in 100 lines of Clojure and with templates and everything. And it's like, I was on my day job, that would have been 1,000 lines of code. And then I got the possibility to do a side project, and basically I couldn't be arsed with Scala's syntax, so I figured I'll try Clojure instead, and it basically got me to where I wanted to be.
But are you following Bodil into the typed language?
Come
on. So are you following Bodil into typed adventures as well? I remember, I think she moved into Haskell a bit and then Rust a bit as well.
Yeah. No, I'm not following her there. I sort of fell off in Clojure land. But what's kind of interesting is that a lot of the things that I found nice with Clojure was that you get stuff done, which is kind of easy but not simple. Mm-hmm. So you have this like you can slurp things from a file, right?
Yeah.
This is easy. It's not simple. Whereas Java has input streams and buffered readers and whatnot, which is simple, but not easy.
Yeah.
And you have the bean library or the bean function for Clojure, which lets you read Java bean. This is also easy, but maybe not simple. So I got into Clojure for all the easy stuff. And I guess I stuck here for the simplicity.
Nicely put, yeah.
But how did you, so one of the things that I think in the beginning you're talking about the scaling up Clojure to multiple teams, etc. And so how big is your team and how are you handling that? Because this has been one of the discussion points everywhere. And then like, oh, dynamic languages, they can't scale and it's difficult to maintain large code bases.
Yeah, so we have a fairly simple product implemented in a fairly difficult way, if you will. So we have some 40,000 lines of production code, which has been written over since 2013, so over 7 years, with a fairly stable bunch of people. Started out with the founder. He wrote like a lot for the first 2-3 years. Then we got one more on board. Then I came, and then now we're 4 more. So we're about 7 on back end.
Okay. And the whole application is a Clojure script or
But no, it's Clojure and then it's JavaScript on the front end.
okay. But why
And
JavaScript?
because there were 2 founders, one on the back end, one on the front end, and the one on the front end, he knew JavaScript.
That makes sense.
Yeah. So now they're converting all their stuff to TypeScript, and that's sort of when I stopped contributing to the front end.
Hmm.
Right.
So there was no
But
push for, oh, we have all this Clojure and it makes sense to have Clojure script in the front end.
No, we have a little piece written in Clojure script as well, but that's a side thing.
Okay.
Yeah. So it seems this is sort of not a critique of my current colleagues, but critique of programmers in general, is that we seem to be very sort of complacent. It's like, oh, I know this stuff.
sure.
I know my Java. Why should I change? It's not that bad. So, so
Yeah.
trying to show people a better way of working it's futile.
But it is really tricky, right? Because
Let's not go quite that far, though, Erik. It's like, let's stop the wrist slashing at this point. It's like I don't think all hope is not lost. It's like, but I think that one of the problems with selling Clojure script, to be totally honest, is that it depends on the people you're selling it to, and it depends on the problem you're addressing and all these other things.
Yeah, and I think it's like the tooling might be, and I'm not talking about just compiling Clojure, but like all the tricks and all the trivia that you know about CSS and know about JavaScript and you know about the libraries,
Exactly. Yeah.
then you don't exactly know how to solve these problems. You don't know how to use Clojure script in anger.
yeah.
And especially
And
if
I
you've
totally
already
get
got
that.
like a fairly complicated application on the front end, the prospect of porting that over to Clojure script without any, it depends on what you perceive to be the actual value to the business and the value to your ability to deliver to that business. Because JavaScript's dynamic, you can do things quite quickly. People, they're not always looking for the most perfect solution. They're looking for a practical solution. So if you've got 1,000 or 10,000 lines of JavaScript, the cost of porting that could be quite high. So I don't blame people for not doing it.
No, but I find that I've colleagues that work in or friends that work in Scala, and they've sort of introduced Scala in a company where a lot of people do Java, and they're not interested.
Yeah.
It's like, oh,
Well,
I have
that's
to learn
reasonable.
something new.
Yeah. Yeah.
That's
But there is
tiresome.
a balance, right? Because it's when you're trying to solve a problem, there is a balance between, okay, I know all this stuff and that can solve these problems because it's proven that it can solve the problems. And now I don't know anything about this new shit, and then now I have to figure out everything,
Yep.
and I don't even know whether it is going to solve my problem in the same way or not. So I think for the greenfield projects, it makes more sense because you can just start off and then it's easier to start a new technology. But if you want to port
Yeah,
something, it's mental.
I've been working on a bunch of Java programs or Java projects where I wanted to convert to, earlier I wanted to convert to Scala and later to Clojure,
Yeah,
and it is not something that really makes sense to me,
yeah,
because you have to not only, if it's only me then it's fine, but there's a team, so the team has to want to do this, and the
yeah,
team has to be motivated to learn Clojure or Scala or whatever,
yeah,
and your application has to be written in such a way that you can actually start rewriting it, because it doesn't, and that's something that's going to have to be done over a long period of time. So you have to be able to bite off small chunks, rewrite that, and then continue, because if you have an app of like 50,000 lines of code, then it doesn't make sense to stop shop and re-implement it in whatever other language.
yeah,
I mean, you have to be really suffering. That's the point. Yeah, you have to be really
Yep.
suffering with that. With like you're completely unable to deliver any new functions, or you're finding bugs, things are failing left and right. I think that those are the kind of motivations that make people change. I don't think people. I think there are a lot of 9-to-5 programmers for sure who don't give a shit what language they're programming. They just want their money, and that's fair enough. By the way, it's okay.
Yeah.
But
There's nothing wrong with it.
no, I mean it's a job.
Yeah.
They're just punching out code for someone, for
Yeah.
some big corporation. So fine, let them do their work, But I think if you're kind of like passionate about a particular like beauty or elegance in a programming language or a programming environment, then I think that's what makes you come to functional programming in general, isn't it? But a lot of people don't understand what the sorry.
That's when you start porting everything to Arc.
Yes.
You can really get shit done.
Exactly.
Yeah.
But I think what the reason why these days, my stupid brain starts to think in terms of a more managerial perspective, because I've been managing people for, I don't know, for some years now. I think the whole idea of, okay, let's introduce new technology. I think the whole idea is function of three different things for me: the people who are working in the team, and that one, and then technology, and then third one is the business context. So the whole change is a function of all these three, and
Yep.
I can't just change one thing and expect that it's gonna work. If I introduce a new technology, people are gonna fucking leave. That's it. They're like, okay, I don't like this shit. I'm leaving.
Yep, and that's a problem in sort of our line of work, is that I jokingly say that probably even in these Corona times, I can have 13 new jobs tomorrow, right?
Yeah.
So if someone does something that I really don't like, I can just leave.
Exactly.
So you have to be really careful with that. But flipping that over is that I think for us, having Clojure as our language has given us a lot of smart people that we otherwise wouldn't have gotten.
Yeah.
And we're competing in a very, very small pool of other companies for these developers, right? If you hire for Java, then you're competing with everyone.
Yeah. Yeah, and of course the business context makes sense as well. I mean, for some business contexts, obviously Clojure is not going to be suitable,
No.
depending on where you are, and where depending on what type of problem that you're solving. So obviously we want to do Clojure everywhere, but there are some domains that they're not there yet, or there is not enough libraries or whatever, and so it's always a tricky balance.
That's also something that I try to stress when I present my views on Clojure and my sort of experiences, is that I work in web development.
Yeah.
I have continuous integration. I have continuous deployments. I'm a REPL away from production.
Yeah.
I have my build pipeline, so I can get a fix from like commit to being in production is 2 minutes. So there's a total difference from that and shipping CDs to I don't know, Mars or something.
Yeah.
Sure.
That's so. Speaking of because you said ClojureScript tooling and everything, it's a bit of a difference between, or a gap between Clojure tooling and ClojureScript tooling. So Emacs or some other shit?
Emacs.
Okay.
And there was a dark period in my life. I started out, Emacs was my first editor. That was what we were taught at the university. And coding Perl in Emacs is obvious.
Yeah.
Coding Java in Emacs is not so obvious, even though there were some efforts. So at some point in time, I said, I will never work in a language where there is no decent IDE.
Yeah.
Right. So I used Eclipse for a long time. And then coming back to Clojure, it's like, yes, now I have Emacs again. And it's like, I will never work in a language where I have to have an IDE to work.
That's a full circle.
Yeah.
The funny thing is, actually, I've got completely the opposite experience, because maybe it's because I don't know Emacs very well. I used
I think that's the problem.
Yeah, it must be.
but it was like left and right for me. It was like VI or Emacs, and I went VI because.
But you know that Emacs is the superior one there.
Yeah.
Well, I think, to be honest, it was a practicality. I mean, for me, it was I could always use VI even when I logged into any system that I logged into. I could use VI. I
Yeah,
didn't have to install a tool chain. Whereas that's the problem with Emacs. I think Emacs is like for people who want to sort of sit in their own space and program their own environment. But if you're doing like admin tasks for, like system admin across 100 boxes, well, Emacs is not a good place. There's no point in
that's
learning it
how I
because
learned
you can't
VI.
use it. Yeah, exactly. Yeah. So that's that's where I learned VI as well. And once you've kind of like put a year into VI or something, well, I could learn Emacs, but again, it's like one of these like complacency things. You know, why should I unlearn all this stuff? And from everyone that tells me it's pretty fucking awesome, but fine.
I mean, there is a difference between drive-by editing and Formula One editing.
Sure,
It's
sure, yeah, yeah, I get
there
it.
is certainly a difference. So if you want to
Yeah,
do drive-by editing, like, oh, I'm going to just jump onto the server and then
yeah, yeah,
remove a couple of lines and then restart a service and then go home, and then that's a drive-by shit. So
yeah,
that's fine.
Yeah, but
absolutely,
the
yeah,
thing with Emacs is that it makes perfect sense when you're used to REPL-driven development, right?
Yeah,
Because
yeah,
Emacs is a REPL.
yeah,
So, like, I was listening to Bojidar on the REPL podcast here the other day, and it's like, how do you develop stuff in Emacs? Well, you just go into where the source is and you evaluate the new function.
yeah.
It's instant feedback. Then you can say that Emacs Lisp is probably not the most beautiful language, but it's Lisp.
I mean, it held up for 30 odd years, so why
Yep.
not? So, or even more. I don't know, 60s first one, but
What I was going to say to you though was that, like, from an exploratory perspective, IDEs are very nice. Like, for instance, recently I've been doing some Go programming and C programming and also some Clojure programming all together, and I've got like 3 IDEs open, like all from JetBrains, like the Sea Lion, the Goland, and the IntelliJ. And it's really nice because you've got all these like similar things to explore the functions, to explore the code, find usages. There's perfect debuggers on all of these IDEs, so you can trace what's going on in all languages. And I've got to say, for me, that's been really a perfect experience.
But I think you get some of that. I'm not saying you get it as good. I will admit that. But the language modes for Emacs they're quite similar. Now, uh, I must admit that find usages in cursive is really, really good. And even though
Mm.
Emacs has, or Cider has now something similar, I don't trust it.
yeah.
So when I want to figure out where a symbol is used, I can either grep or I can use IntelliJ.
Recursive awking. I still do that occasionally.
Because I think cursive and IntelliJ has the MPI thing, like there is a semantic model behind it, which makes it easier to walk through the
Yeah,
code.
I mean, it's very
Yep.
nice across these different languages to have a
Yeah,
very similar experience, and it's very powerful.
yeah, yeah.
So I agree. I think if you're very familiar with Emacs, it's great, but I would just say that fuck you.
But on that note, though, I think that one thing that's really interesting is the work that Petter Strömberg has done on Calva
Oh yeah, yeah,
for Reach.
Mm,
And also, I'm really happy to see the work that Bojidar is putting into the orchard. So and he
yes,
yeah.
and the way that he's sort of taken the custom code that is specific for Emacs and he pulls it back into these libraries that are
mm,
usable
mm.
for the whole community is just that's software development as it should have been done.
Yeah, definitely. No, he's a hero of that in that respect for
Yeah,
sure.
Yeah.
and I
Well, he's a hero in
remember
many respects. Yeah.
Stuart Holloway was saying that you don't write lining in plugins, write libraries, and then write plugins for those libraries.
Mm,
And that's basically what Bojidar is doing now: is pulling
Mm.
these specific things and then making libraries out of them.
yeah.
so that the nREPL middleware becomes really, really thin, and it's just a connector into the interesting bits.
Yeah.
Yeah, I've used the completions library from Orchard in a REPL that I wrote, and it's fantastic. You know, it's great that you
Hmm.
can do completions in a bespoke REPL. Yeah.
Yeah.
So it's been, I mean, because we're talking about different libraries and people, contributing to different stuff. So it's been almost 7+ years in Clojure for you already, right, Eric?
Yeah.
2013, is
Yeah.
that? Yeah. So
Yeah.
what is your experience with the community? What are the good and not so good things in the Clojure world?
The good and not so good things is that I'm trapped. Um, I have a really hard time seeing myself working outside of this community and
Mm,
outside of this language, because I sort of feel at home,
mm,
and I feel it's possible to contribute. Whereas in Java, it's too big, and JavaScript is also too big. It's like you're just there. I can have a conversation on Slack or on Twitter with Alex Miller, right? Uh,
yeah.
that's harder to do that with Brian Guts.
Mm,
I don't know where his Slack is. Um, and I think that there's a couple of years ago when in the Clojure community there was like almost an uprising that Cognitect is not listening to us, and all that stuff. But I think they brought their point across.
mhm,
They do the core of the language, and unlike other languages in Clojure, it's possible to write your stuff on top of what core gives, and that's sort of one of the value propositions of a Lisp. And I think one of the things that I sort of created was the speculative thing.
yeah.
So someone was creating or complaining on Twitter that, oh, there should be specs for the
Core.
Clojure core conf function, right?
Yeah. Yeah.
And then, why don't, well, if you want that, why don't we just set out and make it?
Mm,
And the interesting bit was that I think there's a handful of contributors to that.
yeah.
So people like to complain about stuff not being there, but they're not so eager to contribute, maybe.
Yeah. Maybe it's a good idea to just tell us what spec is and what speculative is.
Yeah, so Clojure spec is, what is that? It's something that replaces schema. Um,
I think you don't need to tell us what spec is. I think most of the people listening will know what spec is, but
yeah.
maybe it's not speculative.
So speculative was just a collection, or is a collection of specs for the core functions in Clojure.
Yeah.
So that now Michel Borkent has, I mangled his name, I guess. He's taken over that project, but it's basically just specs for map, for filter, for the most used core functions. So
Yeah.
now you can basically run your program or your tests with spec, and you can get to know if you call the core functions wrongly.
Yeah. But do you spec in your production code base or your
Yeah,
company code?
yeah, we do. We have we have spec, we have schema, and we have CLJ schema. So we have like three generations of spec tools.
Okay. So you're on spec 2 or spec 1?
Spec one.
Oh, okay.
Spec 2 even out yet?
Yeah, it's out. You saw that on 1st of April on Slack, didn't you?
There was spec 3, I think.
Yeah, spec 3. Yeah.
Yeah, there was spec 3. Yeah.
Yeah.
That was hilarious.
So we also used spec tools from Atosin
Hmm.
quite a bit. Um, but we've moved a little bit away from that now, and we wrote at RDoc, we wrote our own little piece of spec tools to do swagger generation for Composure,
Yeah.
where the spec tools thing did too much for us.
Yeah. So your backend is mostly APIs, so it
Yes.
really has more synergy there, I think.
Yeah.
Okay. Nice. So,
And yeah, go ahead.
no, go ahead. Sorry.
So one of the things that we kind of like and don't like about Clojure or about Spec is that it's open.
Mm.
So I like to think of it that Spec is sort of data interface,
Mm-hmm.
whereas schema is more like data classes, right? Because in schema, if you try to pass more data than the schema says, then it blows up.
Yeah.
That's really annoying until it isn't.
Yeah.
Because it stops you from storing the whole of Wikipedia in your database. But when you want to add one more key, you have to update the schemas, and that's also annoying.
Yeah. But this is the thing about required, like a kind of a view into the data that you're processing in that function in specs, right? You can uh, do optional only
Yeah, but
part of
there's
the data.
the thing is that if you have spec that says that you have a required key,
Mm-hmm.
which is an int, and you have an optional key, another optional key, which is a string, then if you pass those two, then they have to conform to the spec, right?
Yeah.
But nothing stops you from sending a bunch of other keys that nobody talks about.
Yeah. Yeah. So it will accept the data that doesn't
Yes,
have specs. Yeah. Yeah.
which is nice, but it also means you can't use it to sort of stop getting data into your database that you don't want there.
Yeah. Well, I mean, if you have a database, then obviously a database will have some sort of a schema, right? That is going to
Well, you could think so,
kind of block you.
but MongoDB
Unless you've
doesn't
got
have a schema.
MongoDB. Oh, you have.
Yeah.
Okay.
I mean, I said database. I mean,
Yeah,
come
sorry,
on.
my fault. Yeah,
Yeah.
No, but I think what you're saying is, I mean, clearly you could write, and maybe see you've even done this, write something yourself to police that interface.
yeah,
But what you're saying is that you can't leverage spec for that, and that's a shame.
yeah. Or that's not what spec was designed to do.
Yeah.
Sure, yeah. I mean, it's designed for a certain reason, but I think, as far as I know, like if you were at Clojure Tray, Alex was saying that although they want open by default, they're going to provide some tooling in the upcoming version of spec that will offer you the ability to say only a certain set of keys must be passed. And
Yep.
so I think they have listened to people in that respect, because they know that there are some APIs, for example, that will only accept a limited range of keys. So even if
Yep.
they maybe don't want that in their Clojure interfaces, they accept that there are some existing interfaces out there that will not tolerate that kind of open key space.
Yeah, but I think it's interesting from like if you look at how your code base, your internal code base becomes when you use spec, it's you program against interfaces, which is really nice, right? You
Yeah.
say that, oh, the thing that I'm passing here has these keys, but it might have a lot of other stuff that I don't care about. And I think
Mm.
that makes it possible to evolve the code base over time so that not everyone has to know about all the data that's passing through the system. It's um, it's like with if the internet had to know, like the protocols had to know about every little bit and piece of data that's passing through, it wouldn't have worked. But you have a
Mm.
protocol that says that a TCP thing is this and a payload.
Mm. But it depends on the domain as well, right? Because the keys are probably representative of the domain, and if the domain doesn't change that much, then you can actually restrict what you're passing, or pre-design this is how it is going
Yeah,
to
but
be.
there is a function called select keys.
Mm.
Yeah. Yeah. Yeah.
Yeah, I know, but it exists, and it's existed for quite a long time. So
Yeah.
if that's what you really want, just do that.
Mm.
Yeah.
And that's a thing that I've seen in sort of there's a conference here in Oslo called FlatMap, which is basically a statically typed functional programming conference.
Right.
And what I see is that they argue for functional or for static typing, and they're saying that, oh, I changed this one thing here, and I see like I get a ton of red things over there, and my compiler says that this is not going to work, right? But to me, that indicates that there's a design problem,
Mm.
because you shouldn't, like, changing one thing over here shouldn't give you 100 errors over there.
Yeah.
Yeah, I mean, it makes it very brittle. I mean, that is the fundamental problem with these very kind of complicated type systems, is that they're sort of magical and they can do great things. But you're right, they constrain you and concretize your implementation. Quite kind of, and I think again, maybe in certain domains that's really important. That, you know, in medical equipment or something, or certain types of environments where, you know, you want to be 100% sure, or you want, you want to have sort of mathematical proof that this thing is correct, then, you know, maybe that's okay.
Yeah, and I think that's one of the things that one of my problems with functional or with dynamic languages is that I feel that I have to defend the usage of dynamic language or dynamic types, right? Because I'm choosing away some sort of security measure.
Yeah.
I was thinking about it from a climbing perspective. It's like I'm choosing to climb without a rope because I don't fall.
Such climbers exist, I think.
Oh, they do. They do.
Not many, probably.
Definitely.
Oh, free climbing is quite popular, I think.
Free climbing, since I'm a climber myself, free climbing is climbing with a rope, but not using other things than the rocks to get yourself up.
Oh, right. Okay.
In comparison to aid climbing.
What's the other one? Sorry.
Aid climbing. That's when you put stuff into the rock and you pull yourself up on those things.
Oh.
What's the one where you don't have any ropes then?
That's free solo.
Oh, okay.
Yeah.
Now we know.
Now you know. So there's this movie, Free Solo.
Oh yeah, isn't the guy got into an accident and then he died, right?
No. I think Alex
Is it a different
Honnold
guy?
that's a different guy.
Okay, yeah.
And I think none of the guys that really been on film actually fell down.
Oh, okay.
Yeah.
Is this the guy who was going through that Catalina or something, the big super flat things in the US?
Yeah, in El Capitan.
Yeah, sorry, El Capitan.
Yeah.
I'm just picking some Mac operating system. Probably Maverick, probably.
Right,
I don't know.
right.
Is this the guy who climbed Mountain Leopard? Oh, maybe. It has a mountain in it.
Yeah.
But where do you when did you start climbing? A long time ago, or are you?
Yeah, before I started programming.
Whoa, okay.
So I started climbing when I was 17 or 18, which is late now, but that was sort of halfway early at that point.
Okay. Yeah. And what is the I don't know, levels, grades, whatever that you crossed already? Is it like skiing? Like the black ones are difficult and
well, and outside there's grades, and we use sport climbing grades, or at least what I do. And they go from 3 to, I think we're up to 9B or something now. And I stopped at 8B.
Wow. So you can do that Tom Cruise move in the Mission Impossible thing.
I would think so, yes. Yeah. Yeah.
Nice.
So you could be a chimney sweep.
I probably could be. Yeah.
It's an alternative career, fails. You know, if the Clojure thing doesn't work out.
Exactly.
So
anyway, can we just go back to your talk in Clojure D?
Why?
Yeah.
Well, because
what's
I'm
wrong with
completely
climbing?
unqualified to talk about climbing, and neither are you. So,
well, I'm completely unqualified to talk about Clojure as well. So I have equal.
Fair enough. Yeah. Okay. Back to climbing. Okay. Fine.
So climbing and Clojure, because they're starting with CL, I guess.
Yes. Exactly. Yes.
you planned this thing since the 90s.
80s actually.
Oh, sorry, 80s. Yeah.
Yeah.
All right. So Ray, you're talking about Clojure D.
Yeah, you asked the question right at the beginning about the topic of the talk at Clojure D, and I don't know if we've already covered it or whether we should now bring that round to it.
Yeah, so we can bring that back. So basically, it was a list of things that I think are important if you want to write maintainable Clojure.
Hmm.
Okay. Well, let's
Uh,
have an argument about that then. Yeah.
yeah. Okay. Um,
I always like these manifestos that people make, you know. So let's get it going. Yeah.
so I started out with an article from that Erik took up on his podcast, which was Stratified Design by Abelson and Sussman,
Hmm.
and where they go about and they talk about how if you want to write maintainable software, it has to be somewhat more general than what the specs are saying, because things are going to
Mm.
evolve. So you're going to have to make sure that you have room to evolve. And they say that you do this by doing a stratified design. And so, what is stratified design? And I think that the thing that I brought up in the talk is that, and that Erik Assum also brought up, is that we use maps to model our domains, right?
Yeah.
Mhm.
But as you walk down through the layers in your stratified design, up at the top, you talk about a user.
Yeah.
And then you should do operations that are sort of relevant to the user. So if you're working on a user, then you can do change password,
Mm.
right?
Mm. Mm.
Whereas when you go down into the layers, you're operating on maps.
Mm.
Then
Yeah.
assoc or dissoc are nice things,
Yeah.
Mm.
but you shouldn't assoc and dissoc on a user like at the top level. Maybe you do that inside a function, but the operations that you do on a user should be at the user level and not at the map or seek level. Does that make sense?
Of course, yeah, absolutely. I mean, you know,
Yeah.
you kind of have different what should we say, different degrees of different degrees of of of, of
Abstractions.
yeah, abstractions, but also I'm thinking of like
Generalities, I would say, because at top you're very specific.
Hmm.
it's like parochialism, isn't it? You know, at a certain point there are parochial concerns, you know.
Mm, That's a very difficult word for me.
Oh, I mean, they're like local concerns. They're concerns
Yeah.
to you in the local place that you are.
Yeah. And so the next thing that I think I brought up was be careful to name things. Like Clojure is a language where you don't have to create a user class, right?
Yeah.
We have a map for that,
Yeah.
but it might be useful still to sort of have this user thing in your program if your program is about users. And I think even more important is to name your anonymous functions.
Yeah.
Because both in Clojure and in JavaScript, I think I see a lot of map some sort of anonymous function over some collection.
Hmm.
And unless you're building like Clojure core, then your application is probably not about mapping, filtering, and reducing, but it's about the things that you map with, or you reduce with, or you filter with, right? So those are the things that you should name.
Yeah, but this is probably similar to your first point as well, right? Because the
Yeah.
mapping and filtering become like a sort of a implementation or a lower level things.
Where do
Yeah.
you draw the line there, though, Eric? Because you know, one of the nice things about about functional programming is that it can be anonymous. So there is a kind of like, and I think Zach Tellman said this, you know, that in his book, which is that if you don't have to name something, then you shouldn't name it, because actually naming things is a pain in the ass. You're kind of stuck with a name. So names can be nice sort of for debugging purposes if you're doing like partial functions or whatever, but generally kind of naming things is a burden. So
Yeah, but
why do we
I
have to
would
name
then,
things? Maybe I'm missing your point there.
well, that this point was brought up after the talk as well. I think that in Elements of Clojure, Zach Tellman says that avoid naming at all costs. No, he doesn't say that,
No.
but I would argue that if at your application layer you have problems with naming stuff, naming the operations that you do on your users, then then you don't understand your domain.
Oh no, that's fair enough. Yeah, that's fair.
Yeah.
Yeah,
But
sure.
what I really like is when you have like a threading pipeline that you don't have to say that, oh, on the one side of this thing, I take a user, and then on the other side, I have this slightly modified user, which I have to call something because it's a class. And then, through the pipeline, you have to
Okay.
call.
Yeah. Yeah. No, I think everyone can kind of get on board with those distinctions. Yeah.
But do you mainly use maps, or do you reach out to some other things like records?
No, we use maps.
Okay.
Yeah. But, I mean, we have Mongo, right?
Oh yeah.
So basically, it's JSON in, and then as
Yeah,
little as
yeah.
possible transformation, and then JSON out.
Okay. Yeah.
Yeah.
Because I think designing the domain.
It's like the programming equivalent of the human centipede.
But I think that's interesting. I mean, we have 70,000 lines of code, including tests, right? And basically, all we do is we take JSON and we store JSON and we deliver JSON.
Yeah.
Why do you have so much code then?
I can tell you a couple of reasons, I think. One is that we, in my sort of humble opinion, we use Mongo the wrong way.
I don't think there is any right way to use Mongo, but that's what I heard on the internet.
I think there is. But if you try to use a document database as a relational database,
Oh yeah.
you're asking for trouble.
Yeah.
So instead of having our data sort of stored in documents, we have a bunch of relations.
Mm.
And then we have to do all the constraints management
In the
ourselves, making
application
sure.
level. Yeah.
Yeah. And Mongo has schemas,
Yeah.
but we're not using them. So we have to make sure that the data is correct in the application layer.
Mm.
At the time when we started using Mongo didn't have aggregates, which they have today, which means that they didn't have joins.
Yeah.
So we have to do joins in the application layer as well.
Yeah. That's a lot of data moving around.
Yes.
So you adopted Mongo in the same way as you adopted Java, basically, before it was ready.
Yeah, I think so. And the problem with Mongo is that it keeps getting slightly better.
Yeah. So you're not really pushed over the edge.
Yeah.
Exactly. It's like, oh, now they have transactions too, right?
Yeah. Yeah.
So you don't have that argument either.
But I mean, it's really interesting how they took over the whole, kickstarting a project phase, like Ruby on Rails. It's so easy to get started. So just type MongoD, and then you're ready, and then you can just show whatever the thing that you like, and then build the stuff up from that one.
Yeah, and I think Bodil's talk from Öredev there, that she used Mongo as well, right? And that sort of it saves you a lot of time in the beginning because you don't have to define the schema. You can just hammer stuff into the database and it's happy.
Yeah.
Which is great. But then when you sort of mature, you start paying for this because you don't know what's in the database, and it just becomes a mess to clean up.
Yeah.
So you would say, just so I understand it, back to your point, then you've got these 70,000 lines, and it's basically because you're essentially doing the work of Mongo, the work that a database should be doing, or that a relational database would be doing. You're doing that in your application.
Yeah, I'm not saying that we would get rid of all the code, but a lot of the code could have been done in the database. Yeah.
Mm-hmm.
Yeah.
Of course, we could have written the whole thing in PL/SQL as well, and everything would have been in the database.
Oh yeah, of course. I mean, I think one of the Oracle 9 had a PL SQL HTTP server.
Yeah. So you could write.
Times.
Yes.
Oh yeah.
Like, come in, keep shoving shit into the database itself, like.
Yeah, but it's also, why would you want to write HTML in SQL?
Well, if you're from Oracle,
yeah,
you really want people to do everything in the database, so you can charge for, I don't know, key typed, whatever. They have amazing licensing policies. So,
but to circle back to the talk a little bit, Another thing that I've used a lot of examples from our code base, which is interesting because our CTO started using Clojure when he didn't really know it. So we have a lot of gems, good examples of what not to do.
I guess you've got to be a little bit like, oh, dude, I'm going to talk about this amongst the whole Clojure community. I'm going to shame the shit out of you. Are you okay with that?
I'm fine. And
no, you are. What about him? No.
He's fine. He's
okay.
He's given up coding. He's not coding anymore. But
okay.
But that's an important thing, though. He did whatever he did in best effort, and they got this company off the ground. And it's actually viable.
Yeah.
So, that's the thing when you do sort of retrospectives, and I brought this up a little bit in the talk as well, is that assume good intent. I mean, he didn't sit there and write this, and I'll write this like really convoluted code because I can. No, he did it because that was, how he thought Clojure was supposed to be written.
Yeah.
Or whatever.
Sure. Yeah.
I think always consider the context. I think that was the key. Like understand in which context it's been written, and
And that's also when you do PRs and everything, is that people generally do stuff in good intent. And be nice to each other. It's much nicer that way. But another thing that we have in our code base is overly general functions. So functions that handle anything that you throw at it. And also overly defensive functions, which check for everything. So you don't know if they're just checking for everything because they want to, or because it's actually something that we can expect to happen. And that, as a developer coming afterwards, it makes me insecure of the code. Like, when can the user be null? Can it be that at this point?
Yeah.
And that's where you sort of need to create boundaries within your architecture that you say, on the outside here, the user can be null. On the inside, no, it can't be.
But isn't that the one that type systems are supposed to help you with?
Well, no, because what you see people do, at least in the beginning, with types. So say you have something like a maybe thing, right?
Yeah.
And then, option type. So when people start out, it's like, oh, if option dot has whatever it's supposed to have, then you do what you're supposed to do. Otherwise, you say, I don't have that.
Yeah.
But what you see after a while is that you should do this checking at some boundary, and then all the functions inside should be, I know that I have the user here.
Yeah.
You don't send a maybe user around.
But isn't that a nice thing for spec though? Because like these required keys and stuff like that, we use that so we can have we can have confidence that these keys are required. We don't have to check things because we just do a valid on them. Just check. Well, there is a check, but it's very little from our coding. We just say, well, there has to be a valid user at this point. Otherwise, we're just throwing an exception. And obviously, we're assuming that 99.999 recurring % is going to be fine.
Yeah, but the thing is that down at the say 3 levels down where you persist the database, you shouldn't be wondering if there is a user or not.
Yeah, exactly.
That should have been handled at some other point.
It, but I don't think there's a problem with having a spec to say there must be, for example.
No.
I think that's the difference, right, between Clojure and other languages, because in other languages you're forcing this at every level. So in Clojure you have a bit of a freedom to say the outer layer, because you want to be accepting everything when you're accepting. But when you're producing something, you want to be very clear on what you're producing. So I think the inner layer we can tighten up a bit.
Yeah. I mean, the classic case on the outside is you might have some defaults that you'll fill in.
Yeah.
But you don't want to be doing that every fucking way.
Yeah, exactly. Yeah.
But I think the thing that I brought up in the talk there is that there's a thing about protocols that you should be lenient in what you accept and strict in what you send, right?
Yeah.
But I think that's really nice for APIs, for external APIs, but for inside your code, inside your application, you should be fairly strict on what you accept as well.
But that's still under your control, right? Because API is suddenly an interface that you don't have any control over. For the internal API, of course, what you said makes complete sense, because you're the you're part of the system, so
Yeah.
you know what is happening there. Yeah.
But I do find that, this is to me, by the way, this is one of the things where spec really, really earns its corn, is that if you, on your own internal sort of APIs, if you use spec there, you can be quite rigid with what you enforce, because you know that, okay, well,
Yeah.
I'm not going to put nothing there because I don't want to completely trust that I can't be called with shit, but I can be quite rigid in what I spec and what I say must be there because I'm controlling it. So
Yeah.
I don't need to be too fussy about could be, couldn't be, whereas I am more like that on the outside.
Yeah, because I see we find that a lot from our tests. We run those either with schemas on or specs on, and they catch quite a bit of things. So like you say that I'm expecting something that has this shape and it suddenly doesn't.
We had this guy Jay on recently. We had lots of arguments with him. He was a very funny guy.
I remember that. That was a great episode.
Yeah, it was such a funny guy. Yeah. But what he said, and I really liked. I love orchestra and the sort of stuff he's doing with spec, and I've definitely adopted this approach in my own code as well. Maybe it's not at work yet, but this notion of just instrumenting everything and just taking the hit is, I think, a really good idea. Actually, I think he made a really good point there that although this instrumentation is meant to be expensive, it turns out in reality it's not that expensive. And
we actually had a point like really far. So when we fetch stuff out of the database, I did spec checks on the stuff coming out of the database to see that it was actually, because we don't have a schema, right? So you have to be certain of what's
so
there.
You have like both sides because of MongoDB being external actor for your system.
Yes. So you have specs when you store stuff and specs when you pull it out.
Yeah.
But that was actually turning out to be quite costful for us. So on the sort of entities where we pull a lot of stuff from the database.
In fairness, you're kind of like sitting on way on the extreme there, Erik. Every database access. Okay.
Yeah. Yeah. Yeah, and that was too much.
Yeah, that's fair. That's fair. Yeah, there are limits to everything. You definitely found it there.
Almost like order of magnitude more checks happening every time.
Yep.
It's like, okay, I'm going to insert something into the database. I'm reading, but wait a minute, did I get the data properly back or not?
Yeah, but the thing is that we have old data as well, right? So
yeah,
not
exactly,
all of it
because you're the
checks.
schema. Yeah. No, we had the same, we had the similar kind of thing, but I think our at that time I was writing Akka and Scala and MongoDB. It was because we didn't need any joins or anything, so we did use MongoDB, but eventually you keep evolving the document version to next versions and everything, so that made all the case classes go fucking haywire because everything is an option, because when you read from the database and that it's not going to be there because you fucked up, it was not there before in the domain before. So it was fun. So I can relate to that a bit. But okay. So any other points?
No, I think I've gotten most of the things that I wanted to talk about, but I wanted also to mention that I'm fairly lucky and privileged, working in this domain for so long, and I live in a country where you basically cannot get fired, even if you're making fun of your boss's code. And even if you get fired, you're sort of on Social Security. And so I have like a security network around me, which is super important, which lets you be grumpy at work, lets you ask questions, because question why are we doing this. So that is I understand for other people that is not so easy.
Yeah, that's an interesting point. I don't think I got fired as well, so I know how it feels. Like asking some questions, and then they're like, pack your shit and then go home, and
Yeah, and I think that's
writing Visual C++ code. And
Yeah, I think everyone, I mean, at a certain point, you do get fired. I mean, I've been fired for asking questions, but I think you're right in general that IT is a kind of privileged space, really. If you're a programmer these days, um, in any country, I think, then I think you're in a kind of privileged environment. Yeah.
Mm.
yeah,
And I think another thing that I've learned sort of over the last couple of years, and especially working in RDoC with our CTO, is that a disagreement is basically just a thing, which means that you're not seeing where the other person is standing.
Yeah.
So if I and the CTO, if we disagree, it's not because the CTO is stupid. It's because he has some other considerations.
yeah,
And I feel again there I'm privileged working with really smart people and people that I respect and that I know that I've thought things through.
Mm.
Which is really great because then we can have disagreements and you know that when you come through these that you've actually learned something, both of us.
yeah,
Yeah, I've got to say, one of the things that I do find a little bit annoying in some of the discussions we have with programmers is that they say, "Oh, these fucking idiots have done this, they've done that. Oh man, they're so dumb. They've done this and they've done that." And I often push back and say, "Well, people often take shortcuts for good reasons.
Mm,
You might not like that shortcut. It might not be the most perfect answer, but think about why these people are making these shortcuts. They're making the shortcuts because it's probably the only way they can actually deliver something or get something done because they're getting pressure from their bosses to make something work. They're suddenly, they're storing passwords in a database. They're not salting it or whatever, but that doesn't matter to them. They've been told they have to deliver something,
yep.
and they don't have to have everything completely finished in a perfect way. That's a bad example, but it does happen. Some people are kind of, all about just delivering things for because that's what their project managers want. That's what they need. That's what their deadlines are. That's maybe it's their wages depend on it. So people are under pressure to do these things, even if it's not the smartest thing in the world. So you have to sometimes understand why people are doing things, not necessarily. And I don't think they're always good intentioned either. I think sometimes people just do it because they have to.
yeah,
Yeah, but I think it's also like, again, I'm not scared of losing my job, right? So I can argue that we
yeah,
have to spend some more time and we have to salt these passwords.
yeah,
Whereas if you're scared shitless of losing your job and that's the only way that you get health insurance, then
yeah.
you know you store those passwords.
I think that's a really good point because, as you said, I mean, you live in a environment and context and a country where you have this safety net around you that gives you a little bit more um, opportunity to actually show your courage, or be more inquisitive, or be asked ask questions, or because in the
Yep,
other places, I mean, I'm in both sides, right? I manage a team, and then this so-called psychological safety that you can just say, "Fuck you, Vijay," is pretty okay in my team,
mm,
and you can say that, and you can complain about my code. There is no problem. But how much you even though you say so many things, if I work with a group of people who are coming from a country like India, for example, where I'm from, and there is no fucking way you can say no to anything for
no,
your boss. So, and there is this stereotypical idea of Indian programmers just do this, like waving their heads and saying yes to everything. That is because of that there is no other fucking way. If you say no, you're going to lose your job.
yep,
And but here, because I've been living in the Netherlands for 10 years now, and the Dutch being direct and everything, because there is a certain safety net and equality among people once you step out of the office. So
Mm.
that gives you way more freedom to say what you want to say.
yep.
So I totally get your point. Yeah,
But I think also it's important there to be tactful, and I
yeah,
think it's like there's stuff at work that I might not agree to.
Yeah.
Like, go implement this thing here, and I say, why would I want to implement that? And then it's on me to sort of, it's both on me and my manager, if you will, to get the understanding of why this is important, because
Yeah.
nobody's asking me to do this feature because they think it's fun. It is because we have like an idea of this being important.
Yeah. Yeah.
And that's both on me as a programmer to understand, or to get that understanding, but also on my manager to give me that understanding, I think.
Yeah. Yeah. I think it all brings down to like a code should most of the time have a purpose that is
Yeah.
serving some sort of a problem, solving a problem, or having a purpose. And sometimes, yeah, code is just code. You just have fun and then do whatever you like.
Yeah.
There is time for those kind of things as well. Yeah,
Yeah.
that's a really nice thought. So I was thinking, what do you think that is not so good stuff? But I think it feels like I don't want to end on that one.
Okay.
So I because you've been so kind, and then you explained some of the nice things that I want to leave it at a higher note rather than. I mean, we are pretty much used to complaining about shit all the time.
Okay.
That's what
Exactly.
that's
Yeah.
what we do.
Yeah. Sorry about
Especially
that.
given the. No, so you're breaking the tradition at DefM. But I think these are trying times for people around the world anyway, and it's the kindness should be at every level, at work,
Mm,
at
mm,
life,
mm.
and everything. And I hope everybody is staying safe. And I mean, luckily, all three of us are in a pretty decent countries.
Yeah, and I think it's important. As we started out, Ray and I were talking a little bit prior to the show, and a lot of people are now starting to work from home, right?
Yeah,
And we have to realize that this is not normal distributed work.
exactly.
Yeah.
I have three extremely well-behaved kids running around the house, so I get to work 8 hours a day, even so they're home. But other people are living in smaller apartments with
Yeah,
I don't know, more busy kids.
yeah,
Um, and you have to realize that your productivity is going to drop
yeah,
in these situations.
Mm, mm, mm.
And I hope as companies that we can see past like these couple of weeks and give people some benefit of doubt when the productivity drops a little bit.
yeah,
I think there's also, like you say, Eric. I mean, there are stress externalities, what you want to call it, but stressful kind of aspects to this thing in Europe, where where we tend to have like more safety nets than they have in places like India, even places
Mm.
like the US,
yeah, yeah,
which is a shocking place, really. I mean, it's
yeah,
the world is becoming revealed as the sort of either kind of a nice place to survive a pandemic, or not a nice place to survive a pandemic. And
yeah,
we're lucky to be in a relatively safe place, all three of
Mm.
us. So so yeah, definitely my heart goes out to people that are feeling stress because they have to work at home. Maybe it's even in big houses, or big or small apartments, but if they're suddenly feeling like, wow, you know this whole economy is just grinding to a halt,
yeah,
um and what do I do if I get ill?
Yeah.
This is the thing that really worries me about countries where there's none of these kind of privileges, because they're even scared to go out and call their doctor or go to the hospital,
mm,
because they
Yeah,
could
or
be completely bankrupted
they
by it.
can't even afford it.
yeah,
Exactly.
yeah,
And you can't even afford staying away from work if you're sick, because then
No.
you get fired.
And if
yeah.
that is not a good context for productive work,
Nope.
Anyway,
on that happy note. But I think you're right. I think what Eric said was right, which is like we have to be kind to each other,
exactly.
and think you echoed it as well, VJ. Let's
Yeah,
be sympathetic to our colleagues, and kind to each other in these difficult moments, and
yeah,
understanding of the stress that we're all under.
yeah. So I think all is well when it ends well, and everything that has a beginning has an end. So obviously, things will get normal, whatever normality is, I think.
Hmm.
So and better. So everybody who is listening to the podcast, I think you're staying safe, washing your hands, and taking care of each other as much as you can. And for the people who are affected by it, our sympathies and our heart goes out to you. And
Yes.
uh, so be kind and try to use more Clojure and try to have as much fun as you can. And we hope to bring back the normal times where we can, have more of our stupidity delivered to you in our podcast.
I think there's been a decent portion of stupidity this time. Obviously Eric's brought the good stuff, but we've brought the stupidity.
we tried.
So,
we tried. Yeah,
we've
yeah.
tried.
Yeah.
I mean, we try to deliver on our stupidity direct to your podcast things.
It's been a good talk, and I think that, as I said, my biggest problem with Clojure is that I'm stuck with it.
which is a good thing.
Yeah.
There are worse things to be stuck in. Like awkward programming.
Yeah.
I mean, the ultimate first world problem. Yeah.
Yes.
Exactly. Okay. On that bombshell, we'd like to say goodbye, and we'll be back soon, hopefully in a couple of weeks again. Stay safe and enjoy. Thank you for listening to this episode of DefN. And the awesome vegetarian music or the track is Melon Hamburger by Pizzeri. And the show's audio is mixed by Wouter Dullert. I'm pretty sure I butchered his name. Maybe you should insert your own name here, Dullert. If you'd like to support us, please do check out our Patreon page, and you can show your appreciation to all the hard work or the lack of hard work that we're doing. And you can also catch up with either Ray, with me, for some unexplainable reason. You want to interact with us, then do check us out on Slack, Clojurian Slack or Clojureverse, or on Zulip, or just at us at Defen Podcast on Twitter. Enjoy your day and see you in the next episode. Okay, Defen credits fucking take 27 or something.